Today's lesson we are reviewing a very important topic from, and that is factoring. In Algebra 1 you spent a lot of time learning and practicing how to factor. Hopefully for most of you, after we do a couple of them, you'll remember it and it should hopefully be pretty easy. If not, you are going to need to do some extra work because most of the rest of the chapter, each topic we study, one of the steps is to factor. So if you can't factor, you're stuck at wherever that step is. So you absolutely need to be able to successfully factor for success in this unit. So today we're not going to be reviewing all of factoring. We're just going to be talking today about factoring quadratics that have GCF, or greatest common factor, and then ones that are of the form x² plus bx plus c. So, learning goals, I can factor all quadratics using GCF, greatest common factor, and I can factor x² plus bx plus c quadratics, including difference of squares and PST. If you don't remember what those are, hopefully after we go through some examples that will come back to you as well. So we've got a three-step plan for today with all of our quadratics that we want to factor. You need to go through these steps every single time, and the only way, if you are not good at factoring, if you don't remember it, the only way to get better is to continuously practice. So if you need extra help, please see me. I would be happy to spend some time with you. Step one is to find a GCF if possible. Not all quadratics have a greatest common factor, but if it does, it has to be taken out first. This is like a factoring order of operations. So really important that you find the GCF if there is one. So the way that you do that, in the parentheses, we've got questions that you should be asking yourself. So to find a GCF, you should ask yourself, do all of the terms, not just two of the terms, do all of the terms have a factor in common? It could be a number. It also could be a variable. So you need to look at all three and see if there's any factors that they have in common. So if I look at example 1 and I look at all three factors, I always look at the variables first and then the numbers. This one has x², this one has x, so these two have an x in common, but the third one doesn't have an x. So the GCF is definitely not including a variable. But if I look at the numbers, all three of these are divisible by 6. So we factor out a 6. So whatever they are all divisible by is what goes out in front. So the 6 goes here. What is left in the parentheses, this is really like division. If you're factoring out a 6, that means you're dividing each individual term by 6. The 6 goes in front, and what's left is exactly what we would get from simplifying this. 6x² divided by 6 is x². 12x divided by 6 is 2x. Negative 36 divided by 6 is negative 6. Remember, with factoring, one of the most important things is that you can check your answer. If you distribute or FOIL back out, you should get your original. If you don't, then it's not a correct factorization. All right, so I would like you to look at example 2 here, look at the variables, look at the numbers, and see if you can figure out how to factor that with GCF. So it shouldn't take too long, so quick pause, and then when you think you've got it, unpause so that you can check your work. So checking your work, if I look here, I look for the variables first, and all three of these have at least an x, so I know that my GCF is going to have an x with it. When I go to look at my numbers, 4 and 8 are both divisible by 4, but 6 isn't, but all three are divisible by 2. So I'm going to take the 2 out in front. And so then remember, what goes inside is what you would get from dividing each term by that 2x. So 4x³ divided by 2x is 2x². Then 6x² divided by 2x is 3x. Negative 8x divided by 2x is negative 4. So this would be our final factored answer for this one. Okay, so that's GCF factoring. Hopefully that looks vaguely familiar and you remember that now. Second type of factoring is playing the game that we call factors that add. And we play this game when we are factoring things that are of the form x² plus bx plus c. And the way that you play the game factors that add is you ask yourself this question. So notice in parentheses here on all of these, what I've listed are questions you should be asking yourself. So for GCF, do all the terms have a factor in common? Is it a number or a variable? Down here, you're asking yourself when looking at the problem, what numbers multiply to give you the last number? So multiply in this case to C, and add to give you the middle coefficient. So we're looking for what multiplies to C and adds to B. So looking at example 3 here, you would always check for GCF first, because again, that's step 1. It's like an order of operations. But when I look here, all 3 don't have an x in common, and they can't have any numbers in common because the x² just has a 1 as its coefficient. So there is no GCF here, so I go straight to playing the factors that add game. So I'm looking for what multiplies to the last number. So multiplies to 12 and adds to the middle number, which is 7. So that's the question you have to answer. What multiplies to 12 and adds to 7? Most of you can get that answer as quick as I could snap my fingers. 3 and 4, multiply to 12, add to 7. Those of you who are not as quick, you may want to make yourself a list, like a little chart, and write multiply to 12, add to 7. And you could list all the things that multiply to 12. Well, 1 and 12 multiply to 12, 2 and 6 multiply to 12, 3 and 4 multiply to 12. Those are the only factors that are possible. Only one of those is going to give you the correct adding to 7. This would add to 8 and this would add to 13. So only one is going to be the lucky winner. Now, tomorrow in our next lesson, we're going to review the ones where you have a leading coefficient that's greater than 1, meaning it's not x² plus bx plus c. There's something in front of the x². And those we have to do a special adjustment. But for today, we're just playing the factors that add just like this. What multiplies to the last number and adds to the middle. So once you've answered that question, we're still continuing example 3 here. Once you've answered the question, so you can see I've answered the question here by circling my factors, 3 and 4 are the winners. You open your windows. So after you play the game, you open your windows, which are parentheses, and you write in the answer. So we're going to have an x and an x to split up the x², and then the answers to my question, which were 4 and 3. Again, remember that you could check it by foiling it back out. If I foiled this, I would have x² plus 3x plus 4x plus 12, which does indeed give me back my original. All right, so I've got 2 factors that add game. One's for you to try. Don't forget to check for your GCF first and take it out first if applicable. So go ahead, try the 2 in example 4. Pause it while you try to think those through and then come back to see if you've got them correct. Listen and look at my solution. Okay, so example 4a, I look for a GCF first. They don't all have an x, and since this is a 1 right here, there's nothing else that they have in common. So no GCF on example 4a. So I'm looking for factors that multiply to -66 and add to -5. So you can start listing things that multiply to -66. So maybe you're thinking -22 and 3. Well, if you add -22 plus 3, that gives you negative 19. So definitely not negative 5. So I need the numbers to be closer together than that if I want a smaller number here. So maybe I would try 11 and negative 6. 11 times negative 6 is negative 66. 11 plus negative 6 is positive 5. Now, I did this on purpose. If you get the right number, so I've got 5, but it's the wrong sign, I need it to be negative. That means you've got the right numbers, you just need to switch the signs. So let's make this, instead of positive 11, negative 6, let's make it negative 11, positive 6. Now those multiply to negative 66, and they add to negative 5. So these are our lucky winners. So I open my parentheses, fill in my x's, and then fill in my answers. Negative 11 in one of them, positive 6 in the other. And that is my factorization for 4a. 4b, if you haven't tried it on your own yet, pause again, try it yourself, because that's the only way you're going to know if you understand. So first thing, I look for GCF. Third term doesn't have an x, so no variable GCF. All three of these are divisible by 2. So I'm going to take the 2 out. 2x squared divided by 2 is x squared. Negative 4x divided by 2 is negative 2x. And negative 96 divided by 2 is negative 48. So now that I've taken out the GCF, then I go on to my next step, which is the factors that add game. What's the 2 is out front? You don't go back to the original. You're using what you have here in the next step. So I'm looking for what multiplies to negative 48, because that's the last term here, and adds to negative 2. So multiplies to negative 48, and you can use your calculator to help you come up with these factors. But I've got negative 12 and 4, let's say. And those would add to negative 8. So negative 8's it's too big of a value there. So I need things that are closer together than negative 12 and 4. So it's not divisible by 11 or 10 or 9. It is divisible by 8. So I'm going to try negative 8 and positive 6. So negative 8 times 6 is negative 48. When I add them together, I get my negative 2. So there are my winners. Do not forget to bring down the GCF. It's still part of your answer. I'm going to open my parenthesis windows and fill in my answers here. So negative 8 here and positive 6 here. And there we go. Okay, so that's our review of the factors that add type of factoring, the x squared plus bx plus c, as well as GCF. The last thing, if you'll notice from our learning goal, it says including difference of squares and PST. These are what we call special products. The difference of squares take the form a squared minus b squared, which means you only have 2 terms. They're separated by subtraction, and they both are perfect squares, hence why we call it difference of squares. So what I've written out are questions that you ask yourself. So just like the questions you asked yourself in the parentheses up here, what numbers multiply to give you the last and add to give you the middle, this that I've got in the chart are questions you should be asking yourself when you're checking to see if something could be one of your special products. So first you look for difference of squares. You have to check to see if it's a binomial, meaning 2 terms. Does it have 2 terms? Because if it doesn't, it can't be a difference of squares. They also have to be separated by subtraction. There is no such thing as a sum of squares. Then check to see if both your terms have perfect square roots. So take the square root of the first term, take the square root of the second term. If they both come out evenly, then yes, this is a difference of squares if it passes number 1 and number 2. So if it's yes to both, the pattern that this takes is like so. You open your windows. Whatever the square root of the first term was, you fill that into the fronts. Whatever the square root of the last term was, you fill that into the backs, and then one of your parentheses has a plus while the other has a minus. So one of the most common differences of squares that you factored over and over and over in Algebra 1 is x squared minus 4. So if I go through my checklist, I say, is it a binomial? Yes. Are they separated by subtraction? Yes. Do both of my terms have perfect square roots? Well, the square root of x squared is x, the square root of 4 is 2, so yes. So I open my window parentheses and I fill in square root of the first term. I wrote it up here already, is x, so those go in the fronts. Square root of the second term, I wrote up here, the square root of 4 is 2, so I fill those in the back. And then one gets a plus sign, one gets a minus sign. So there's your difference of squares. Our second type of special product is a PST, which stands for perfect square trinomial. So difference of squares, both terms had a perfect square root. In a PST, the first and third terms both have perfect square roots. So your brain, as you're factoring, should be looking for numbers that you know are perfect squares. So 1, 4, 9, 16, 25, 36, 49, so on and so forth. Because when you see perfect squares, if you know these special products, they are so quick to factor because you know the pattern. So on a PST, it takes this form, and the plus or minus obviously is not really a plus or minus. Some of them are pluses and some of them are minuses. But trinomial means there's 3 terms. So you have to see, is it a trinomial, and are the first and third terms both positive? The key here, people miss this one. That has to be a plus for it to be a PST. Then you check, do my first and third terms have perfect square roots? So do a squared and b squared have perfect square roots? Yes, they do. Is the second term, so what's in the middle, is it equal to 2 times the square root of the first term times the square root of the third term? If it is, then you fill it in to a single parenthesis with a squared. Now the plus minus, you know which one it is because it's always the sign of the second term. So I'm going to give you one here. Let's say we had x squared, and let's do plus 6x plus 9. I know that this is a PST because it's a trinomial. The first and third terms are both positive. The first and third terms both have perfect square roots. I always write them down above. The square root of x squared is x. The square root of 9 is 3. The second term is the one you might have to write out. Is the middle 2 times the square root of the first, which is x, times the square root of the third, which is 3. 2 times x times 3 is 6x. So yes, this is a PST. Factored form is described right here. You put a single parenthesis with a squared. Square root of the first term goes in the front, so that was my x. Square root of the third term goes in the back, so that was my 3. Whatever the sign of the second term was, so the sign of the second term here was a plus, so a plus goes in the middle. All right, very last 2 that I would like for you to try on your own. Please pause and actually think through it yourself. Then come back and check to see if you got it right. All right, so on example 5, I see that this is a binomial. So I'm checking for a difference of squares because those are the only ones that have 2 terms. I check to see if both terms have perfect square roots. So square root of x squared is x. Square root of 196 is 14. So now I say yes. It was a yes to question 1 and question 2, so I'm going to fill it into my 2 parentheses. Square root of the first goes in the front. Square root of the last goes in the backs. 1 gets a plus sign, 1 gets a minus sign, and we are done. If you didn't try this one, try it now and then unpause. This has 3 terms, so I'm checking for PST. It is a trinomial. First and third are both positive. First and third do have perfect square roots, x and 7. My middle term, 2 times x times 7 is 14x. We're not worried about the sign, we're just worried about the value. Yes, this is the middle term. So, open my parenthesis, put a squared on it. Square root of the first goes in the front. Square root of the last goes in the back. And my sign in the middle is whatever this sign was. So in this case, a minus. So x minus 7 squared is our final factored answer. Hopefully you now remember this factoring. None of this is new, all Algebra 1. So we need to practice, practice, practice if you're not already feeling comfortable with it. But that is it for this review.